Thank you. So, thanks having you here as an audience. We will talk about AR patterns. It's my side as an engineer, thinking about how to talk about AR experiences, coming from software development. The idea of software design patterns triggered the idea of inventing AR patterns. And my colleague Alessandro.
Hi, I'm Alessandro Holler. In this project, I am from Zurich University of the Arts, from Department Design, and more specifically from the subject area knowledge visualization. It's a very specific and rare specialization to study in an art school. Exists in that form only in Switzerland. And I was called as a designer to contribute on this platform. On the side, I also work in visual communication, having a studio for also scientific visualization.
Okay, so what's the scope of AR patterns? So in AR, we also have these magic moments, and typically you hear then, oh wow, that was cool. But then it stops. So we have no vocabulary to talk about, to explain what is going on or what is the cool effect of that experience. And even if some techie guys are involved, it's hard to explain to colleagues what is going on and how to contribute and to involve in a team work to improve the solution, and especially if you want to have a collaboration between techies and designers and clients, it gets even harder because we have no vocabulary about talking on AR experiences. And of course, then you cannot estimate the efforts that are needed or the goals, etc. So how can we address that? So we try to establish a conceptual understanding and the common language that we can talk about AR specifically. And then we developed some, let's say, solutions that can help to communicate, to design, to elaborate cool ideas on AR, and even use these tools for documenting projects. So, if we do that effort, why can we establish only AR patterns and not XR patterns? The audience would be much broader and the impact would be more powerful. But we decided to keep it the focus on AR only because AR is different than VR. Typically, if somebody is talking about XR, in 99% they mean VR. And we want to express really that these patterns are working in an AR context. And the reason is, in VR, as a creator, you have some kind of God mode. You define the world. In AR, you have no control of the world, of the appearance, of the events that happen. So it's more a creation of intents what should happen. It's very much event-driven if you think about AR design and content creation. And therefore, it's about AR patterns. So we will present 4 solution building blocks. The one is event condition action diagram. The other one is AR patterns in a catalog. Alessandro will talk about the illustration toolkit, and we will provide a GitHub-based open source platform to exchange and collaborate on these ideas. Okay, here are all these parts, and we go into details. So we see AR system as reactive, event-driven systems. Typically, something is detected in the world, so scene understanding is key, and you can detect things in the image or in the video stream or even in the spatial context. And of course, machine learning approaches improve that more and more. You can detect objects and faces and planes. And these detections then can trigger an action in the sense of add an augmentation or any other augmentations. Of course, user interaction is also an event, hand gestures, the pose, the position in the room, the walking around, all these can have effects, and temporal and data-driven events as well. So of course, there is a reason why these no-code or low-code AR editors are mostly based on this trigger action concept. As you can see here in the Apple Reality Composer, also Adobe Aero is using this approach. So what we did is we enhanced this trigger action by an event condition action concept. And this works as an abstraction layer on top of reactive AR systems. And with this, we developed then this event condition action diagram. It's a kind of pseudocode so that you don't have to say, come on, read my source code, but let's talk about AR on a more abstract level. But of course, this is still very techy, and it's not yet the point where we want to go. So the next abstraction level is the AR pattern level. These are typical solutions that can be reused in common problems that occur when you design AR experiences. There, a catalog of AR patterns has been developed. It's about behavior patterns and augmentation patterns. It was presented last year at the EuroXR conference, but still, it's very technical, scientific. It's not very, let's say, understandable in the context of exchanging ideas. So I invited Alessandro to help me in that case. So it's yours.
Exactly, that's where I come in. When we are designing with AR patterns, but also for the people involved. So when speaking about work in my discipline, I like to show a before and after. So a before in a sense of what is the problem that we have established, and the problem would be how to describe an AR pattern in the best way that is understandable for a certain group of people. About that later. And so this was the status quo. We have a short text, for instance, here about the ahead staging pattern that describes in 1 or 2 sentences what is happening. Then we have the ECA diagram that describes it in a more technical, structured way. And then, in the best case, a screenshot from an example. So here we see the photo of a room where an object in augmented reality has been placed ahead of the user. And what I also like to do is to already show the final outcome before I explain how it came to this. So this specific AR pattern, ahead staging, is now described with this simple illustration. It might look a little bit cold and a little bit simple at first, but if you look closely, you see that it describes everything that is needed without words and at a glance. We see we are inside a room, we see it's not any room, it's an interior where people live. We see that there's a user standing on the floor, we see that something is somehow detected or activated, and we see an object which is different from the surroundings. And also that object has an error and an origin. And so with this method, I created a whole series of illustrations for the whole catalog that has been put together for the AR Patterns project. And here we see some of the best of examples. We have area enrichment with the sky in a park. we have an attention director, we have a pass-through portal, and several other examples. So connected with this work, I would like to show you the challenges that we had. So the initial brief was to reach programmers and also people to coding and designers alike. Because from my position, also as a designer, I have been working with AR projects, not really knowing what the possibilities were, so I could help in that direction. And in the team, Philipp and our colleagues could help from the programmer's direction. And we set the task of creating a visual design language which was precise, distinctive, accessible, and also open, so that it's extendable and reworkable by a larger audience. All this with the goal to promote the discussion about AR patterns, their scenarios that they're built upon, and their implementations. So a designer could say, my client wants me to design an AR experience. I wish there was a catalog where I can browse all the different possibilities I didn't think about. And personally, yeah, I also really wished to find a catalog like that. And a programmer would say, I also had this real experience firsthand, my project partner wants me to program convincing AR scenarios. I wish there was a repository with resources and code examples in order to implement efficiently. So this led to the creation of a visual design system. We call this the illustration toolkit. It's based on a unified perspective, which is parallel projection that allows us to place objects anywhere and they always have the same perspective. They are not distorted. And you can make them bigger and smaller and closer and farther away by just scaling them. And then a catalog of instances. You see we have predefined drawings for detection, for augmentation objects, and also for the users. More about this later, how you can find these assets. They are already online and available. And these assets are not only shown like that, but they base on a color coding in order to have consistency and understandability at a glance. So we have specific colors for detections, augmentations, the anchors and the users, and also ways of representations, so they're shaded or not, or they're full color or not. And here's some examples a little bit bigger. This is area enrichment. We see that the sky is detected as a flat surface, and we see that the anchor is the whole screen. So the scene is oriented towards everything that the user sees. And to be a little bit whimsical, this time it's not only cubes, but it's hot air balloons that populate the sky. Here we are in the classic inside scene. We have a picture frame, for instance, in a museum. And we see that it's detected in the green corners. So the system knows it's a picture. It recognizes which picture it is. Then the origin of the augmentation is inside the picture, but the anchor of the augmentation is offset. So we see it's not on the picture. And here, a classic hand pop-up menu. We see that the hand is detected. The origin is on the palm of the hand. It's oriented towards the user, but offset, so not to be on the surface of the hand. And knowing the system, you and everyone in the AR community will be able to create these visualizations, these illustrations, which is, I would say, a certain added value. Because as I know from my professional experience, it's not everyone's thing to produce drawings like that, and even more difficult to have them in a consistent style. So in that use case, I think I invented a novel way to implement AR. I wish there was a platform where I can share my findings and ideas. And this is what the AR Patterns community platform is. So we have the toolkit, which I have presented, and it's accessible through a Miro board and also as SVG assets. We have the patterns catalog that Philipp showed us. We have the event condition action diagram, and everything combined into AR scenarios where we see where the single patterns are put to use. Before I hand over to Philipp again, I quickly show you how to use the illustration toolbox. It's a simple set of steps. You can access the Miro board or also download the SVGs, and you do one after each other. Choose a backdrop, select your props, describe the detection, design the augmentation, very important, include the user, and specify the anchor. Here the anchor comes last because it's easier to put in a graphical way. Of course, when coding, the anchor should come first. And here is a short video how this happens. We have the publicly accessible Miro board. It's a template with all the assets and a blank canvas that says start here. Select the scenery. Here we take geolocation as a detection. Then I would say, yeah, let's put some geometric shapes into the sky. They are triggered when we reach this point in the park. Important, the user. So we take the footsteps. That was the simplest way to see that someone is standing there. And most importantly, how the augmentations are triggered and activated. So they have the origin on the geolocation, but they are offset. They are offset in the sky and in the area surrounding. They don't happen exactly where the georeferencing is. That's it, finished. I sped it up a little bit, but it's still fast to do. And then you can simply export it as a picture that can be implemented on our platform. And now I hand back to Philipp on how to communicate.
Okay, thanks a lot. AR patterns are also documented and here to use. Of course, this is not so easy with drag and drop, but of course you have to train your speech about technical solutions, but there are some ways to go. There is the paper you can read, and we have a website explaining the patterns now in a more visual way with these illustrations. And if you have an idea of new patterns, then you are welcome to contribute and help us to improve the situation here. Also, these ACA diagrams, they are easy to use because they are based on markdown styling. So you can embed them in README files. Of course, it's pseudocode. It's not really as impressive as illustrations, but it's a way to go to detail more technical aspects in an event condition action matter. Okay, and then at the end on this GitHub repo, we also have sample projects that are documented with patterns, with ECA diagrams, and with illustrations. And of course, if you have your own projects documented in this way, we are looking forward to establish a kind of best practice. And therefore, we are very open to invite you, get contributions, get new ideas, and in this sense, we are looking forward to hearing from you, and we hope that you try out all these elements that we provide as an offering. There is the illustration toolbox, which is available as a Miro board, or the SVG files on GitHub.
Development.
Okay.
So it's continuously developed, so more and more assets will come soon in the next months.
Okay, you can use the catalog of AR patterns, the diagram, and of course the scenarios that will grow, hopefully, into more examples using more technical implementations. We started with a few, but we are looking forward to have other players in the field that contribute here. In that sense, I wish you a nice evening, and hopefully we will talk with each other.
Thank you very much. Thank you very much. Let's give one round of applause for the last speakers of the day. So, thank you guys. So, are there any questions? Yes, we got questions.
Thank you. Just before I ask the question, conceptually I think it's a brilliant idea. I've just got a few questions in terms of, if using the gang of four patterns, for example, we know that regardless of language, we can implement those because all OO languages support those features. When you're applying to something like AR, where it's about the actual behavior of the APIs and whether they support, I was wondering how you kind of deal with, differences between platforms and whether all the patterns can be applied to all those different APIs. So, stuff that would work on AR Core that might not work on AR Kit, or if you've got a mobile phone that doesn't have time of flight, that sort of stuff, how you'd handle that.
Yeah, I mean, we try to be technology agnostic somehow, but of course the experience that we had, and my experience is more mobile AR, not head-mounted, had definitely an influence. So maybe some patterns are missing, which are specific to a certain technology, yes. And therefore we are looking forward to get contributions from outside now. Yeah. But I try to have generic abstractions, but this has to be proved that it's valid. Yes.
Thank you. Thanks as well for sharing those. I was wondering what the process was for actually coming up and devising those patterns, how you decided that they were a good way to kind of represent them, what that process was to come up with them.
It was too hard to understand. Have you got it? It's
Also
kind of echoing
didn't really
here.
understand.
So yeah, I was just wondering what your process was for devising, coming up with those patterns, and how you decided that they were the best way to represent them.
Okay, so the AR patterns as an abstraction, they came out of the experience that I made developing my own apps, and also coaching students. And then, the last 10 years, we had some experience in how we can do things. So patterns are somehow reusable solutions, so you don't have to reinvent the wheel. They are established, they work, and that's the idea of an AR pattern, that it's documented and that we have a language to talk about.
So I think the question, what she meant is, how did you ended up with those defined number? What was the process of coming up with just those?
Okay, good question. I thought a lot, I discussed, tried to talk in this vocabulary, and some worked and some didn't really work out, so yes. But I know it's a starting point, and maybe more than these will pop up. Also, the one decision is why are there no interaction patterns? But they are all interaction patterns, so they, maybe we add another category of patterns. Now we have behavior patterns and augmentation patterns, but it's an open discussion. So,
Yes, I think we got time for one more question, and I have some final announcement for tomorrow. Yes.
Is there any difference between using this pattern and making like a scene and using the storyboard to show somebody how it would work?
I think that's maybe more a question for me. Since you mentioned a storyboard, we think that the platform is more a repository for very basic concepts, so that there are only one moment that is happening. But of course, I think the assets could also be used as a storyboard. What I also wanted to say is that the illustration style has been developed specifically, so it's really easy to reproduce and use. That's why it's rather simple. Since it's open, the assets can be reused. And it's imaginable that in a documented example, the visualization consists of several storyboard-like images.
Perfect. Then, guys, Philipp, Alessandro, thank you very much. Thank you very much. And I want to thank everybody. Let's give one round of applause for today. Also, you guys, let me do one thing. Thank you very much for staying. And just one quick thing. So tomorrow, Virtual World Society meeting and breakfast starting at 7:30 at the foyer.